Modern education relies on a core premise. Give a student a web browser with unlimited hyperlinks, and they will naturally pull together multiple perspectives. Over 2 decades of cognitive research show the exact opposite. In a study testing how subjects modeled arguments, researchers Britt and her colleagues found that giving students a carefully structured hypertext presentation provided zero advantage over reading a standard linear text document. The students performed exactly the same. When the hypertext was presented without a strict navigational structure, students actually suffered a measurable cognitive deficit compared to the linear readers. Mere exposure to a vast network of connected digital information fails to trigger the mental processing required to synthesize ideas. Experts physically organize space to integrate complex knowledge. They rely heavily on tactile cues, overlapping stacks, and physical proximity to map out concepts, much like the developmental psychologist Jean Piaget did on his desk. Physical documents possess a spatial permanence. A browser window, by contrast, is ephemeral. Readers scroll past information and flip through fragmented tabs, losing the spatial anchors that tell the brain where a piece of information lives relative to another. When students trained in library and information science evaluate web documents, they consistently apply different, more rigorous evaluation heuristics than untrained digital natives. Deep digital literacy is a learned mechanical skill, not an innate trait acquired by growing up with a smartphone. To achieve true digital comprehension, software must replicate those lost physical anchors. It requires artificially engineered constraints that deliberately restrict user freedom. Effective web-based studying is strictly a function of how task design intersects with rigid interface parameters. To test how interface constraints drive comprehension, researcher Jennifer Wiley designed a study asking undergraduates to determine what caused population changes during the Irish potato famine. Wiley first pre-selected a specific set of documents and completely stripped them of embedded hyperlinks. This single constraint prevented users from wandering off into irrelevant digital noise. Next, she modified the interface. Instead of a standard browser, users were forced into a strict dual-window environment, keeping 2 sources visually accessible at all times. But providing this restrictive dual-window interface yielded only marginal improvements in how well students understood the material. A restrictive interface cannot do the heavy lifting alone. The physical separation of data requires a cognitive catalyst to drive the user to actually connect the information. That catalyst is a specific type of assignment known as a discourse synthesis task. This requires a reader to pull multiple texts, evaluate varying degrees of importance, and actively organize them into a new structure. Researchers paired the rigid dual-window interface with a demanding argumentative essay assignment about the historical event. This line chart tracks the performance of the test subjects. You can see a baseline trajectory that sharply spikes upwards only at the exact intersection point where the dual-window interface meets the argument writing task. The argumentative task gave the students a goal. Knowing they had to connect information across sources forced them to selectively reread texts and actively bridge the data sitting in the separated windows. Digital environments succeed when the assigned task demands deep integration and the software interface physically forces parallel processing. Before users can even attempt to synthesize information, they have to retrieve it, and navigating a search engine requires separating domain expertise from actual web experience. This matrix plots domain expertise on the x-axis against web experience on the y-axis. The upper right quadrant represents double experts, users highly experienced in both the subject matter and internet usage. These users largely bypass search engines entirely, striking direct, linear paths to specific known information hubs. Down in the opposite quadrant are the double novices. These users find themselves trapped in erratic, looping pathways, heavily relying on the back button and bouncing off the target. These novices constantly reformulate queries, pulling in large volumes of highly irrelevant documents because they lack the tactics to refine their search parameters. Efficiently navigating through digital noise relies entirely on mechanical skills that operate completely independent of a student's domain expertise. Once a novice finds a source, they have to evaluate it. Researchers Brem, Russell, and Weems outline 4 explicit criteria required to do this properly: credibility, accuracy, reasonableness, and support. Without strict training, novices misjudge credibility by relying on surface markers. They assume a source is reliable simply because the author has a professional title or because the site lacks a clear profit motive. They judge accuracy based on the sheer volume of details crammed onto a page, entirely failing to cross-reference or corroborate those facts against independent sources. Novices also approach information with a rigid, absolutist mindset. They attempt to categorize every web page as either real science or a deliberate hoax, completely missing the rhetorical nuances of journalistic reporting. Evaluating digital source validity relies on unnatural heuristics. Students do not intuitively know how to do this. They must be explicitly taught to recognize and apply these criteria. Researchers Britt and Gabris identified 3 advanced web literacy skills necessary to navigate this complexity: integration, sourcing, and corroboration. To enforce these specific behaviors, researchers developed a tutoring system called the Sorcerer's Apprentice. The architectural success of this software lies in its rigidity. It takes the highly complex task of document evaluation and decomposes it into a strict sequence of micro subgoals. It uses functional visual analogies, like a digital bookshelf, to anchor the user to the physical cues they would use in a real-life learning scenario. Embedding these functional analogies into the interface successfully simulates expert evaluation heuristics for users who otherwise lack that training. The system enforces a strict mechanical workflow. Users must identify and manually categorize the author's intent before proceeding. If incorrect, the software deducts points and strictly blocks progress until they engage with a specific hint card. This forced active extraction process yielded a measurable outcome. Students who trained with the software wrote significantly better, causally connected essays than the control group. Reading a pre-summarized textbook is a passive experience that gives the illusion of understanding. Extracting raw data and being forced to categorize it requires active mental labor. Short, highly restricted interactive training modules successfully bridge the gap in complex sourcing skills. The modern web strips away vital physical and spatial cues, removing the friction that forces the brain to slow down and process information. Rebuilding that friction requires 3 specific constraints: restrictive dual-window interfaces, demanding discourse synthesis tasks, and strict evaluative scaffolding. Instructional designers must abandon the heuristic of building for maximum access. The new standard must be building for maximum cognitive integration. Digital tools are not inherently educational. Left alone, they are simply unstructured repositories that demand strict engineering to be useful. True digital comprehension is achieved not by setting the student free in the information age, but by deliberately and precisely limiting their movement within it.